Today's seminar is going to cover the laws of exponents. So our goal for this lesson will be I can identify and apply the laws of exponents. So now would be a good time to pause your video and go ahead and write this in your notebook, both the title and the goal. Okay, so then your note sheet that you'll end up getting for this lesson will look like this. And I'll just hand out the full sheet of paper to you. What you'll have to do is just, show you here quick, is fold these parts over here and fold this side over and then just cut these here, just halfway. So you can go ahead and do that. So let's jump right in then. So there are a couple rules that we're going to have to look at. So first off will be the zero exponent, product rule, quotient rule, negative exponents, power of a power rule, and scientific notation is here, but we're going to work on that next week, so we don't have to worry about that right now. But we will revisit this, so make sure you don't lose this foldable here. So let's start with the zero exponent. Zoom in here. Alright, so what I will do is write the general rule here that you'll be following, and then your examples you'll be writing over here. Since this is smaller, I'll write them on a bigger piece of paper, but all of your examples should fit in the example part here on each different section here. So make sure you're writing your examples here and doing the examples that I ask you to try on your own. So first and foremost, the biggest thing with anything to the zero power is that it equals 1. I'll repeat that again. Anything to the zero power equals 1. Now that can change a little bit, but the rule is that it is 1. So repeat that to yourself, that anything to the zero power is 1. Now this second example here, I have 5 times y to the 0. Well, this y to the 0 is 1, but we have this coefficient out here that's multiplied by the y to the 0. So if I did y to the 0, that would be 1. 5 times 1 is 5. So in that case, it turns out to be 5, but y to the 0 was still 1. So let's take a peek here at negative z to the 0 power. So once again, there's a negative 1 in front of here. And that's a coefficient multiplied by something to the 0 power. So we'd look at the power first. Z to the 0 is 1. Negative 1 times 1 is negative 1. So that's really the biggest thing with the zero exponent rule, is that anything to the 0 power is 1. So let's do a couple other examples here real quick, and I'll switch out these papers whenever we get to a new rule. All right. Alright, so again, zero exponent rule, anything to the 0 power is 1, so maybe you want to write that down somewhere. So then this example I have here on number 1 is negative 4 to the 0 power. And so that would mean that there's really a negative 1 multiplied out in front of here, so you have negative 1 times 4 to the 0 power. So 4 to the 0 power is 1 times negative 1. So this answer would give you negative 1. Now number 2 down here is a little bit different. So if you have a negative inside the parentheses, it's going to be 1. So this answer will end up being 1. And what I want you to do is try this bottom one here. So pause the video, give it a shot, and then when you come back, I'll tell you what the answer is to it. So this one here then says negative 2 times x to the 0 power. So x to the 0 is 1 times negative 2 would be just negative 2. So in that case, your answer is negative 2. Let you copy that down. So that's your zero exponent rule. So let's move to the next part then here and get our general rule down before we try examples. So we'll be looking at the product rule. So product rule. And what that says, when you have x to the m, you can zoom in here a little bit more maybe. When you have x to the m times x to the n, so same bases but different powers, what you're going to do is add those. So you would have x to the m plus n. So if you're multiplying the same bases but they have different powers, what you'll do is multiply those, or I'm sorry, add those powers together, but your base would stay the same, so x would still be there. And down here we can have a little bit more complex of a problem. Here we'd have to look for the same bases and then add those exponents. So if I were to do this one, I would have x to the m plus n times y to the b plus d. Because you can only add the exponents together if they have the same bases. So here we could add the x's together and we could add the y's together because they're same base. So again, examples I'll do on a separate sheet, and you can absolutely write those examples down right there. So product rule. First one we have is b to the third times c squared multiplied by b to the fourth times c to the fifth. So what we have to do based on the exponent rule is look for similar bases, and if we have similar bases, we can add those exponents together. So in number 1 here, it looks like my b's are the same. Well, they are the same. So I can do b to the 3 plus 4, and then I have my c's, which is the same base, so that means I can absolutely add those exponents together, multiplied by, which this will be here, c to the 2 plus 5. And just going to signify some multiplication in between here. So then what we can do is add those exponents. So I'd have b to the 7th times c to the 7th. I can't go any further than that, so that'll be my final answer on that one. Now I do want you to try this number 2 here. Just one thing to keep in mind is that any coefficients that you have, those can be multiplied together. So I should have 6 in the front of my answer. So go ahead and pause the video here and try this one using what we learned in the product rule. And your answer to this one should be 6a to the 4th b times b squared times c to the 7th. So after trying that one, and if you didn't get this, try it again or come and see me and I can help you out with that further. So that's our second example there. That's the product rule. If you have the same bases and different exponents, what you do, and if they're multiplied together, is that you add those. Okay? So be referring back to this pink sheet because this will be a big help when looking for which rules you need to use in problems that you're doing. Alright, then let's move on down to the quotient rule. So a couple different versions of it here, which I'll explain in a second. So the general rule that you'll typically see if I can focus this a little bit more. Perfect. So if I have something where I have a to the m divided by a to the n, so I have the same type of bases, same letters here are variables, what it tells me is that I need to subtract those exponents. So I'd have a to the m minus n. And we'll get into what happens if you have a negative exponent here soon when you end up doing this. So once again, you're going to have integer operations here, addition and subtraction, that you may have to take care of because there may be negative exponents that you're going to be working with in some cases. But generally, your rule here is same bases. If they're divided, you do a to the m minus n. Similarly, if you'd have a problem that looked like this, so a divided by b, so different bases, what you need to do with that is put each of these to this power. And if these would have coefficients as well, so like a 1 or 2 or whatever it might be, those would take the exponent as well. You'd put those to that power. So generally this would look like a to the n divided by b to the n. So each of those would get whatever exponent is there. And then last one here, I have a over b to the negative n. Now, a big rule when working with exponents is that you can't have a negative exponent. So in order to take care of this, we would need to flip this fraction in here. So instead of a over b, we'd have b over a. And that would now go to the positive power, and we'll get into this again when we get to the negative exponents. And then, just like we did up here, we have something that looks like this. So we'd need to put each of these to that power. So I'd have b to the n over a to the n. Those are my general rules that I might see when doing the quotient rule. So keep those in mind and be looking for those. So let's do a couple examples then. Alright, zoom out here a little bit. So, first and foremost, what I want to do with this one is take care of these coefficients. So coefficients, you're just going to divide like you normally would. So if I do negative 49 divided by 7, I would get negative 7. And then I'm just going to put everything back that was here. C to the fourth, b to the third, divided by c squared, b squared. Now we got rid of the 7, so this is just a 1 here. So that's completely reduced to there. Now if we think back to our quotient rule, what it says is if I'm dividing something with the same base, so in this case I have c and b, then I need to subtract them. So the numerator from the denominator. Okay? So I would do 4 minus 2, which is 2. So that would be c squared. And then with b, so I should put equal signs in here first. And then I should do b. So 3 minus 2 would be 1. So this would just be times b. And there wouldn't be anything in the denominator because we subtracted those. And if there was a negative exponent, for instance, here, well, then that would maybe warrant something in the denominator. But this one worked out where that doesn't happen. So let's look at number 2 then. So this looks like our other rule here. This looks like a to the n, or a over b to the nth power. So what that says is that each exponent needs to be multiplied by that. Okay? So whatever exponent is here, in this case it was just 1, or n here, so we multiplied by n. But here we have to multiply these exponents together here. Kind of follows the power to a power rule, which we'll get to here in a second. So I don't have any coefficients. So, well, there's 1, but 1 to the third power is just 1, so we don't need to worry about that. K to the 7th, and then this is to the third, so I'd have k to the 21st power, because you're multiplying, times t to the 27th power, and we can't forget about the denominator here. It's the same thing, that's that rule. So I need to multiply this 2 by this 3, which would give me h to the 6th. So I'm just going to look this over. Do I have any bases that are the same. Well, I have k, t, and h, so no. So I don't have to do any other of the other rules here. Now just keep in mind, some of the problems might be more complex and may apply 1, 2, 3, or all of the rules maybe, so you have to be watching for those. Now I would like you to try number 3 here, and this is going to follow this rule here. So the a over b to the negative n power. So look at the general rule here and see how you have to follow that. So pause the video here and give this one a shot, and I will write down the answer for you once you've taken the time. If you don't get it, then go back and try it again, or if you're still stuck, ask me for help. So after I would flip this, I should have d squared over 2a to the third, c to the sixth, and now it's to the positive 3 power. And now we would just carry out what we did before here. So 2 times 3 would be d to the d to the sixth. It's a bad 6, but that's a 6 there. And then I have to give this 3 to each thing that's down here. That includes this 2. So 2 to the third power is 8. 3 times 3 is 9, so a to the ninth. And then 6 times 3, which is 18, so c to the 18th. Final answer would be d to the 6th divided by 8 times a to the 9th times c to the 18th. Now I'm going to check this and see if there's any similar bases, to see if there's any other rules I have to apply, and the answer here would be no. So that's our final answer there. So that's the quotient rule. So just a couple more rules here, and then you'll be on your way to be able to work on your exit slip. Okay, so like I had mentioned, you can't have any negative exponents in your final answer when working with them. So I'll show you what you need to do with those. So here I have x to the negative n. That's a no-no. We can't do that. So what we would need to do is then put x to the n in the denominator of a fraction, and that would be 1 over x to the n. So essentially what you're doing is you're just flipping it over. So anything to the negative exponent turns into a fraction. It's smaller than 1. So 1 over x to that power is what you would have. Now similarly, if I would have something here like 1 over x to the negative n, that's a no-no again. So what you do is you just bring this x to the negative n to the numerator, and then that negative will become positive. So this one's x to the n. And you might have something that's complex like this one here as well, like x to the negative c over y to the b times z to the negative d. Well, we have negatives in there, and those aren't okay to be like that. So what I would be doing is bringing the z to the negative d to the top. So I'd have z to the d, because when you switch it, then it's positive. Y to the b would still be in the bottom. And z to the negative, or I'm sorry, we moved that. Then this x to the negative c would have to come to the denominator. Then it would just be x to the c. So with negative exponents, you're either moving things to the numerator or you're moving them to the denominator. That's really all you're doing with that. So let's go ahead and try this quick then with the examples that we have. So looking at your sheet then, if I have something to the negative exponent, it's 1 over whatever that is. So my first answer here should be 1 over b squared. So that one's pretty quick there. The second one here, yes, you can have them like this. So what I see here automatically is that I need to put x squared over 1, or x to the negative fourth, and make that 1 over x to the fourth. But that's still multiplied by y squared over 1. So if I would multiply those together, do 1 times y squared and x to the fourth times 1, I would end up with y squared over x to the fourth. And that would be how to do number 2. So again, I want you to try number 3, so go ahead and pause the video here, and what I will do is give you an opportunity here to try it, and then if you don't get it right, try it again, and if you need more help, please ask me. So a correct answer here would be 7xy to the 6th over p squared. That's your correct answer on that one. So last but not least, we have the power rule here. And what we have with the power rule is a couple different examples here. What it says is that, in your general form that you'll have, if you have, need to zoom in here quick. So if you have a power to a power, what you're going to do is multiply those. So this one would look like a to the m times n. Similarly here, if you'd have two bases with different powers, you're still going to multiply those powers by each other there. So this one would look like a to the x times n times b to the y times n. We kind of did that in that quotient rule already down here. Down here we did that. So we'll refer to those examples as well. And last but not least, you can have this with the coefficient, and this coefficient needs to take this exponent as well. So this one would look like 5 to the nth power times a to the m times n. Then let's quickly get to our examples here and be referring to this while we're working through them, okay? And when you're working through your examples, refer to this and write them here like we had talked about. Okay, so like I said, you have to multiply these exponents together. So x to the 3 times 2 would be x to the 6th. Y to the 5th times 2 would be y to the 10th. So that's the final answer there. And we didn't have any coefficients, so we didn't have to square any of those either. So let's look at number 2 then. Leave that one up for a second yet. Number 2. So we need to give each one of these things that are in here, we have to multiply them or put them to the third power. So this 5 to the first power here, we need to do 5 to the third power, which is 125. Don't do 15, it's not 5 times 3, it's 5 to the third power. And if you ever have a variable that doesn't have a power, well, it's always to the first power. So in this case, we do y to the 1 times 3, which would be y to the third. Then I would have next, x to the 3 times 3 would be x to the 9th. And then I would also have z to the 7th times 3, which would be z to the 21st. And that's your final answer on that one. So like all of these that we've been doing then, I want you to try this last one here. Give it a shot. If you don't get it right, try it again. If you need help, ask me. And your answer for this one should end up being a to the 10th times b to the 22nd. This one you'll also have to refer back to your product rule because you'll have some exponents that you'll be able to add together. So give that a shot. If you don't quite get that, let me know. I can help you out. But in general, these are your exponent rules here. Zero exponent rule, product rule, quotient rule, negative exponent rule, power of a power rule. And like I said, sometimes you might have one of these to do. Sometimes you might have to do all 5 of them that we've talked about in one problem. It just depends. You have to be able to identify those and apply them. Which brings us back to our goal of the lesson, which was laws of exponents. That's what we looked at, and our goal was I can identify and apply the laws of exponents. So as always, if you have any questions about this, please see me. Otherwise, you should be well on your way to meeting this goal.